This video is to go over homework 2A, lesson 2.02. Problem number 7 says, define the following words or symbols. A says congruent. What does it mean by congruent? Okay. So define that. B, what's this symbol? And what can we use for? Okay. And C, what is this? Actually, we didn't go over this one, so I can give you the answer right now. This is what we call it perpendicular. This is a symbol for perpendicular. You see, you should watch this video because sometimes I give out the answers. Number 8, standardized test prep. Anna has a simple rule for deciding which symbol to use. Objects are congruent. Object means, the shapes, right? And the measurements of objects are equal. So for example, angles or lengths, those are equal. Which of the following statement is not written correctly according to the Anna's rule? So for example, let's go over A. It says segment DF is congruent to segment RT, and segment is an object, and the congruent, we only can use it for object, which actually is the answer for this one. Oops. So this is rigid, right? How about B? How about C? How about D? Which one doesn't make sense? Number 9. Oh, actually that's number 8, sorry. Number 9, are all equilateral triangles congruent? Explain. So the question 9 is asking, as long as it's equilateral triangle, is everything congruent? Again, I want you to think about the definition of congruent. Okay? There are two things. As you know, it's same shape and same size. So that's actually a hint. And the next one says polynomials are shapes that are made of squares. The size of polynomials means edge to edge with no gaps or overlaps. The three shapes on the left are polynomials. The three shapes on the right are not polynomials because the squares do not meet edge to edge. So that's the definition of polynomials. And the following problem is about you use these ideas. Dominoes. How many different polynomials can you make with two squares? So problem number 10, that's actually number 10. If you have dominoes, like two squares like this, how many different ways can you make? Okay, I'll give you a hint. So if you have two squares, how many different ways can you make something like this? Well, you can make this and you can make this. Are these congruent? The congruence doesn't really matter how you position the shapes. As long as the size and the shapes are exactly the same, we call it congruent. Therefore, these two are exactly the same. So you cannot say these two are distinct dominoes. That's one of the question. So what if you have 3 squares? How many polynomials you can make? So that's one, right? You place those things one, and there's actually, I can make something like this, those are the 3 squares, so that's another trinomials. Yeah, is that the answer for problem 11? Yeah, because if you put it like this way, these two are exactly the same thing. And if you make something like this, it's going to be the same thing because you're just simply rotating this guy 90 degrees, so. Alright, so that's lesson 2.2. Oh, actually, we have problem 13. Combine the t-tetromino polynomial with 4 squares at the right with another tetromino to make an 8-square polynomial. Polyomino. How many tetromino shapes can you combine with the t-tetromino to get this shape? Combine the t, okay. After I consider problem number 13, I think they forgot to put the picture of this shape, because at the end it says how many tetromino shapes can you combine with the T tetromino to get this shape. So they forgot to put this shape, so we can really do this problem.